Hello students, and welcome to a emergency session on how to do chromatography. So it was brought to my attention just the other day that the lesson on chromatography needed just a little bit of work, which is okay, and it's all right. This is one of those lessons that's, you always get it better after you get to do a lab. So we're going to quickly do a little chromatography lab here. So what we're going to do is we're going to go ahead and work through everything here in the chromatography video. And for this lab, you're going to need a couple of things. First, you're going to need to have 2 pencils. You're going to have some sort of filter paper or some sort of paper that can absorb whatever liquid you're going to be using for your mobile phase. You're going to need to get a ruler because you're going to have to measure and quantify the RF values for the different liquids that you're going to be using. You're going to need your markers that you're going to be testing. You're going to need some tape. You're going to need a beaker or cup that will be able to hold your liquid. And then you're going to need a mobile phase or your solvent that's going to be able to dissolve whatever liquid you're going to be trying to tease out the dyes from. So what we're going to go ahead and do first is we're going to go ahead and take our liquid and we're going to go ahead and place it into our beaker right here. Okay, and we really only need a little tiny amount of liquid in here. And the idea is that this liquid is going to end up getting picked up by the paper, and it should hopefully pull along our dyes. I'm going to add just a little bit more because this is a pretty thick piece of paper here. And in this case, we're going to be using isopropyl alcohol. We're using isopropyl alcohol because it has some non-polar and polar elements to it. Then what we're going to do is we're going to go ahead and take our piece of paper and we're going to measure it against the beaker here. So we want to make sure that our piece of paper stands so that its bottom is on the bottom of the beaker and that its top is just barely above. Then we're going to go ahead and take our pencil, we're going to roll it in, and we're going to tape it shut. Okay, so now at this point, we have this attached to our pencil. What we're going to do next is we're going to go ahead and draw our start line. And our start line is going to be a line that we use to indicate where the dyes started off at. Okay? So we're going to go ahead and draw a start line. We're going to draw it all the way across our paper, and we're going to draw that with pencil, which is why you needed a pencil, a second pencil for this experiment. Now, we drew our draw line there. Notice that your draw line, you want to make sure that your draw line is above where your liquid is, okay? So here, our draw line is definitely above where our liquid is, and the whole point of that is that we want to make sure that as this travels up, it picks up the dye and carries it upwards towards the top, and that it does not dissolve the dye in the liquid itself. Okay, so we want to make sure that our start point is going to be a little bit higher right at the line where we're going to fill this to. Okay, So I'm going to try and prop this up here. Okay, success. Okay, we're going to do this craftily here. Set this down. Alright, and see right now it's right at our draw line, which is where we want it. Then what we're going to do is we're going to go ahead and take our samples, so whichever ones we're going to test, and we're going to go ahead and start with a green Sharpie. For today, we're going to go ahead and draw one dot right on the line, okay? Because that's our starting line. Then we're going to grab a second marker. This is a Lowe's marker. We're going to draw that one right on the line. We're going to do a third one, which is going to be a brown Sharpie. And we're going to draw that one right on the line. Okay? Now what we're trying to do is we are going to go ahead and test and see, okay, we have 3 markers here. Do these markers have any of the same dyes? Are any of the dyes that are in these markers in all of them? Are they in only 1 or 2 of them? And what can we tell about those dyes? Okay? So what we'll do now is we'll go ahead and take our chromatogram, which is this. This, by the way, the paper is called the stationary phase. The liquid's going to be called our mobile phase. And we're going to go ahead and drop it in. Okay? Now it's important that the line is slightly above. It really should be at the water level, but we'll go ahead and just make a note of that in our error form. Now, as you guys can already see, or maybe it's difficult for you guys to see, but now we can see it. You can see that the water, or the liquid that this is in, is starting to creep up the paper. And as it creeps up the paper, what's going to happen is it's going to go ahead and grab onto those dyes. And as it grabs onto the dyes, it's going to pull the dyes forward. And it's going to pull some of them forward. At this point, this is kind of like a little bit of a waiting game until, it all, it completely works. So I'm going to go ahead and set this up so that you can continue to view it. Hopefully we'll be able to get a good view. If you look towards the right, it looks like the brown one is already starting to move forward. Alright, so as we can see, exciting times ahead. So, it is a very droll type of thing, so I expect that, you guys should be able to fast forward here for a little bit here. But ideally, you do see that the dyes are starting to pick up and be carried by the solution. The top of where the solution is our solvent front, and the solvent front, as this goes along, is going to continue to move forward. All right. So as you notice here, you can go ahead and see that, especially with the green dot, that we have almost full separation there. So the dye is being carried right along with the solvent front. So just know that that indicates that that dye that's in there is going to be a very, very light dye. Okay. Do 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 do. Alrighty here. So what we're going to go ahead and do here now is, because this has sat long enough, okay, and I'm going to mark that it's 26 minutes even, then I'm going to have you guys come back to the video at. And what we're going to do is we're going to go ahead and measure from here to find our RF values, okay? So what we'll go ahead and do is we'll go ahead and take our sheet of paper out, and obviously you would prefer to leave this for a good hour or so if you were doing it yourself. And we're going to go ahead and mark right here where the solvent front is. Okay, so in this example, this is our solvent front. Okay, and then what we'll do is we'll go ahead and mark each spot right in the middle of where our different things are. Okay, so I'm going to go ahead and grab a special pen here. Okay, and right away, what we should be able to notice, first of all, is that for two of them, so for the brown marker, we can see that the brown marker is made up of at least two different dyes. Okay? Now you could tell that because it has two different distinct colors. We can also see that the black marker was starting to differentiate there. And if we had enough time, we'd be able to see that differentiation just a little bit better. And perhaps I'll go ahead and re-prep this another night, and we'll go ahead and make a whole nother one here for you. And that should be a fun time for us. And then the last one, the green one, looks like it's made up almost all completely of one, and that it seems to be a very light dye. Now, what we're going to go ahead and do now is we're going to go ahead and measure and figure out our RF values. Okay. So remember, our RF values are our retention factor, or the retardation factor of the various things. We'll go ahead and start by measuring what our solvent front is. And it looks like it's 2.7 centimeters. So we'll go over here. Solvent front is 2.7 centimeters. Then what we do is we're going to go ahead and measure from our solvent A. So solvent A, and keep in mind I'm trying to hold my phone and do this. And it looks like solvent A, or solute A,